Okay, so the problem today is 3196, maximum total cost of alternating subarrays. So you are given an integer array nums with length and the cost of a subarray nums L to R where 0 is small. Okay, so like L and R are all in the range of 0 and n, and the cost will be defined as nums L minus nums L plus 1, L plus 2. Why this is minus, this is okay. Then the last one will be nums R multiplied by okay, so it is like a minus, a plus, a minus, and a plus. So your task is to split nums into subarrays such that the total cost of the subarrays is maximized. Okay, so maximum cost, ensuring each element belongs to exactly one subarray. If nums is split into k subarrays where k is larger than 1 at indices I, then the total cost will be k subarrays integer return the maximum total cost. So like every split you have to count the cost and then add it up. Like the first split is okay, then that's so if I will give some examples and see if I really understand the problem. So okay, is there so that for numbers in the nums array, will there be negatives or 0? Yeah, it will have negatives and you will have zeros, and the length will be at least 1, so you can have 0, and the cost will be zero. And if we have like -2, 8, and then 3, we can have cost we can have cost like if the whole array is a split, then the cost will be like negative. I think we will first have this is -7, or we can have yeah, the group is like and if we have group or we can have group like this, or we can have group and this will be -2 plus 8 minus 3, and it is -3. And this will be so it is 9, and this is, oh, they have the same. So the answer will be 9. So let's look at the last number. Yeah, I think we have to check every combination of groups and then count the cost of every combination. First we have to calculate the cost of every group with this formula, and then we will sum up all the combination of the group. We'll sum up the combination of groups, and then and see which combination has the maximum maximum cost. Yeah, so if written in code, I think let's see if it can so if so if we look at the last number, if we take nums I minus 1, if nums I, let's say if nums I if nums I is selected into the group, then problem shrinks to finding finding maximum cost in the rest of the array. Or if we don't select okay, so or if nums okay, let's say if I minus 1 is a group, and if this is a group, then we will have to find the maximum cost in nums 0 to I minus 2. Okay, that sounds reasonable. Yeah, then we will have to like calculate the cost here, and we will check if this like every combination, this is one combination, and we will see which combination generates the maximum cost. Yeah. Okay, so I will have that first search to do the recursion. So I have the I defined as the total cost like the maximum the max total cost of subarray I. Right now 0 to I. So DFS I will be we'll have cost function, and it will be, we'll send the array as parameter, so it will calculate the cost for me. So if like the group is this, we will find like this is the cost like, yeah, if we make this a group, like nums I minus 1 to I into a group, then the total cost will be, and it's okay. So Yeah, but DFSI will be like this. We will loop through all the combination and try to find the maximum cost. So it will be like this, like and this is I minus 2 cost of nums if I minus 2 till I is a group. Yeah, and then it will be one DFS 1 plus cost nums 1 till I. Okay. Yeah, we'll have this like the cost. And for DFS 0, plus cost nums from 0 till I is a group, like the whole array is a group. So if the whole array is a group, then DFS 0, the cost of like the maximum total cost of subarray 0 to 0 will be an empty array. Then it will have cost 0. So boundary are if I is 0, return 0. Time complexity will be it depends on how like we also need to know the big O of the cost calculation. I'm thinking of pre-calculate the cost of each subarray, then since the cost calculation okay. So I will say it will be nums with the power of 2 we don't know the cost, the big O of cost calculation, so then we will have calculated time complexity later on. For the cost, I'm thinking of like the pre-calculation. So first I'm thinking of like also do dynamic programming of approach to calculate the cost, but I don't know if it works since it kind of like yeah, like the yeah, it has to multiply by a -1. So I don't think. Yeah, I think maybe we should calculate all of the Okay, for cost, let's say if cost I, it will be, oh, sorry, cost I, cost j till I, then yeah, the definition will be the cost of subarray nouns j till I. Yeah. Then cost ji will be like nouns j minus nouns yeah, I'm not sure, like okay, this will be negative. Yeah, like this, with the power of 1 multiplied by nouns j plus 1, and this will be power of 2 multiplied by nouns j plus 2. Then it will be nouns no, we won't have I, we will have I minus 1. And this will be I minus 1 minus j. Okay, so so I will have an array, like a matrix to memorize the cost. So I will have cost 0, and that is multiplied by n plus 1 for I have n plus 1 rows. Since I would like to access, like I will be n, so I should have n plus 1 rows, n plus 1 columns. So for j in for j in range n plus 1, for I in range n plus 1 cost j I equals how to calculate power in Python. Oh, it will be like yeah, I think since I will not move and j is getting larger, so yeah, let's say if I is for this, if I will be 4, and j is 0, 1. Yeah, like I will be 4, and j will be 0, 1. Oh no, sorry. I will be 3. Yeah, because the length is 3. I will be 3, then j is 0, 1, 2. So is it like the power of j? No, I don't think so. If j is, yeah, like if it's this one, then I is 2, then j is 1, but but this should be 0. So it will be, I think it is I minus 1 minus j. Like I is 2 minus 1 minus j. Okay, then the cost is done, and we will move on to the DFS part, the split part. So it will be DFSI. If the I is 0, then return 0. Then else we'll have for loop to loop through every combination. We'll have j for j in range I. Then we return max value. Like DFS I minus, no, DFS j plus cost I j. Yeah. Okay. Will we have boundary problem? Like, should we give a default if I is 0, it will be, if I is 1, then j can be 0. I think there's no problem. And then return DFS n. Okay, we don't have n definition, so we will have length nums. Okay. Oh, we should start it from 1. Oh, yeah, like ij will be like j the smallest. Yeah, we I think the problem will be here. For I in range. Yeah, because I have like it should access and for I and it's just started from 1 because there is no 0 for I. I'm thinking if, yeah, like I think the problem lays in under the cost calculation. I think this has no problem. So cost ij is yeah, like j till I minus 1. This is j. And r is I minus 1 minus j. don't see any okay, maybe let's try run. Okay, so this will be easier, I think. If this is so the array will be this, and then cost will be 0, 0, 0. Oh, it is like so it will be like this. And okay, so I'm going through the for loop here to calculate the cost. Okay, so for I in range 1, it will start it here. It will be like cost 1 0 will be cost 0 so like cost right here, cost 1 0 is equal to nums 0 1, and for 0 1 it is 1. So will it calculate, and it is cost calculated by I is 1, 1 minus 1 is 0, 0 minus 0 is 0, so this is 0, and multiplied by nums 0, so this will be 1, this will be 1, so correct. Then cost 1 1. Oh no, we will not have 1 1. Yeah. So we then move on to I is 2, J is 0. Then we will have nums 0, 2, and 0 2 is 1 minus -1, so it is 2. And let's see if this is calculated correctly. It will be -1 with the power of I is 2 minus 1 minus 0, which is 1, with multiplied by 0. Oh. It is not correct. Yeah, something is missing. You cannot like this yeah, it is like 1 minus the negative. This should be also a for loop. You have to sum up the array, like starting from I till J. No, this is J. So this is I, and so it is starting from let's have index and range starting from J till I, and the index and index as well. So some. Okay, let's see if the calculation is correct. So this will be for every index in range 0 to 2, and this will be -1 with the power of 2 minus 1 minus 0, and multiplied by nums 0. This is this will be 1 minus this will be -1 multiplied with no, I think this will be index. Yeah, so this will be 0, and the next will be 1, and this is 1. Yeah, this is correct. For this, yeah, why this is 2, like, it's so weird. Yeah, and I'm curious, like, what is its cost? This is a group, yeah, if we can have a group like this and then this, it can have 10. Or if we have a group like this and this, it can also have 10. So this will be 0. Array will be 0 with 3, 0, 3. So it's 3, 3 with 0 is 6. Yeah, correct. And this will be array, subarray 3 till 4. So 4, 3. Why is minus 4? Yeah, something may have been incorrect. So if cos, okay, this is if cos 4, 3 equals 3, 4. It should be 4, but instead it is -4. So let's see what is. Okay, so it will be a for loop, index in range 3 till 4. So it is -1 with the power. Oh, it starts with 3. It should be started from 0. So and this is 3. This is correct, but it should be started from 0. So we should minus j. Okay, let's see. Oh, forgot having a catch. Okay, then yeah, for this the time complexity is kind of O and 3. Yeah, since there is a for loop here as well. Okay, well, it has a big number, so we should use like an ON solution. I will first change this to a for loop. then let's see. Okay, so maybe this, like the bottleneck is here, so maybe this should be optimized. But we'll see if we can. We'll have a max cost array to memorize, to keep track of every subarray, so every combination. So it will be 0 with n plus 1 and 4 for I in range 1 till n plus 1. Max cost I will be maximum cost j plus cost ij for loop. Okay, you can check. Want to check the solution. Okay, so like this, like for 3 it can be, it is previous to plus the next, and for 4 it is it will be 3 minus less than, oh, it will be thinking of maybe cos ji is caused will be like cos ji will be cos sense, like so it can be rewritten to cos ij is cos I minus 1j plus like this. Yeah, it's because it is still like the time complexity is still in with the power of 2. Okay, I have read the solution, but I am not like really understand it. Yeah, like they simplified this this whole thing. Like okay, I will write it down here. That they said you can look at every like every number in the array as like they have yeah, if they are in the odd like they are placed in the odd number in the group, then it will be a plus for the number. But if a number is placed at an even number place, then it will be a negative. So there will only be like two states. It is a big time complexity ON solution. So like if once I is at ones is at first, third, or fifth place of its group, then it will be plus I. Else for example, like second, fourth, sixth, then it will be negative I. So it will be written as DFSI equals maximum, see whether this which one, like negative or plus or positive, is larger. So maximum of DFSI, like the previous one, will have norms I and yeah, kind of like this. Well, yeah, I am not like really understand. I agree with like these two statements, but it seems too simplified. Like, yeah, because not every number can have a minus option. Yeah, for example, like this one, like if it is always the first element, then it will not have the negative option. And like the boundaries will be I equals like if I is smaller than 0, then return 0. think DFSI here is the max, like the max cost of subarray. I plus 1. Yeah, so yeah, like if you see 3 as an example, it will be, yeah, there are 2 options, plus or minus, and yeah, it depends on whether, like, which place are you at in the group. So if you are here, like if you are all here, it will be a plus. Then if you're at the second place, it will be a minus. But I am not sure, like, yeah, like its relationship between I and I minus 1. So yeah, I'm thinking of, like, this is better to understand. It's okay. I think I may have some idea, like, so to form the plus of 3, look at these 3 examples, and it will be, yeah, like the problem will become finding the max cost of subarray in the nums I 0 to I. Yeah, 0 to I minus 1. So kind of makes sense. And then for this, like this one, then you will have to have this I minus 2. Then yeah, and then you have to add this one and then minus yourself. Okay, let's stay with it. So if I is smaller than 0, then return, let's say if I is equal to 0, return 0, like it is the maximum cost of subarray from nums 0 to 0, like 0 to 1, then okay, so return num 0. If I is smaller than 0, return, and there will be an empty array, so return 0. Okay, then we'll write it here. So it is like DFS I smaller than 0, return 0. If you are not at the boundary, then return maximum. And the entrance of DFS will be n minus 1. Okay, let's see. Then we will have for loop. First have a maximum cost array to keep track of the cost. So it will be 0. And they are in. I think we can have like 0. Nums 0. And I will have like this. We'll have n plus 1 and max cost one will be non-zero. Okay, so for I in range n max cost I plus 1 equals maximum cost I plus nums I and max cost I minus 1 will be nums I plus nums I minus 1 minus nums I. And return the maximum cost n. Right. This is okay. I found something weird. If I is 0, then this is maximum cost 1. Bit 0. Okay, it will be. It's not. We'll have it like this.